Duct leakage is one of the biggest problems affecting comfort, efficiency, safety, and health. On this program, the first in a series, we will introduce you to one way to measure duct leakage, known as the Infiltrometer flow hood technique. This involves using an Infiltrometer blower door to depressurize the house, with the central air handler fan off, and then using an airflow capture hood to measure the duct leakage coming out of the grills and registers. This technique is especially appropriate on an initial sales diagnosis, in order to prove to the homeowner that they have a duct leakage problem. It really backs up the smoke demonstration of their problem by putting some hard numbers onto the extent of the duct leakage. Having an actual measurement of leakage then allows you to estimate how their duct leakage is hurting their system's efficiency and output by using Comfort Institute's SEER and AFUE degrade analysis. This test is quite straightforward. However, there are many little testing details and issues you'll need to know and understand. On this first program, we're going to demonstrate the complete test from start to finish so that you can grasp the big picture. We'll touch on many of the issues involved, but avoid going into a lot of detail. Future programs in this series will expand on the details. The house we'll be testing today is about 50 years old and is located in Greenville, South Carolina. It has about 2,100 square feet of living area on a single floor. The house is heavily shaded and is on a sloped lot. There's a large ventilated crawl space under the house. At the back, the crawl space is very tall and actually has a tuck-under garage built in. There's a slab near the garage door and a dirt floor everywhere else. There's actually a stair going up to the living area above, with a regular-sized basement door at the top. So in a sense, this crawl space could be called a dirt floor basement. In any case, it is unconditioned and vented. All the ductwork is located in the crawl space. The house is cooled by a 2.5-ton air conditioner that was installed about 8 years ago. A new sealed supply duct system was installed about 2 years ago. However, the original return ducts were kept as they were, left unsealed and tied into the new return plenum with an April air filter. The original returns are all low wall returns on the outside walls, which is usually an inherently energy inefficient design. We first tested the whole house air leakage. It was quite leaky, as it needed 1.7 square feet of leakage in order to achieve the right average natural ventilation rate, but actually had over 4 square feet. The smoke puffer inspection found the usual leaks in the house envelope, including these recessed can lights and this extreme leak around the dishwasher. The overall duct system showed up to be extremely leaky when checked out with the smoke puffer. This is a floor supply, and here are some of the outside wall returns. Clearly, this duct system is a real leaker. Remember, the system circulating fan is not running at this time. This duct leakage air is being drawn in to replace the air being blown out of the house by the infiltrometer. The basic principle of the Infiltrometer flow hood duct leak test is that if outside air is being pulled through duct leaks into the duct system by the infiltrometer, we should be able to measure it with a flow hood as it exits the registers. The smoke puffer makes the leakage visible, and the flow hood will quantify it in terms of CFMs. By the way, if the duct system were truly airtight, no air would come out of it with the infiltrometer running. The smoke would just sit there and we'd get a 0 reading on the flow hood. On a future program, we'll explain how to modify this procedure to test a tight duct system. Before going around with the flow hood and measuring the incoming air, there are a few preparation steps to take care of. First, if you haven't already done so for the whole house blower door test, you have to prepare the house. For example, windows, outside doors, and fireplace dampers closed, water heaters and furnaces disabled or on pilot, all fans off, and so on. Now for the duct leakage test, if it is possible to do so, we recommend trying to open up the space where the ducts are located to the outside. The test works better if the pressure in this duct zone is as close as possible to outside atmospheric pressure. In this case, although the crawl space already had some open vents, we decided to also open a window that was in the tall garage area of the crawl space, as well as the overhead door. If there had been the usual crawl space hatch, like you see here in a different house, we would have opened it instead. We'll discuss how to prepare for basement and attic duct applications in more detail on a later program. Next, we changed how the tubing was set up that is connected to the blower door's manometer. We'll go into exactly why this is necessary on the next program. The long and short of it is that instead of referencing to the pressure outside, in this house we're going to run a tube down into the crawl space because that's where the ducts are located. The 2000 series Infiltrometer has a digital manometer that can be removed from the console or control panel. Just carefully lift the gauge from its position by pulling on the gauge. It's simply held in by a magnet attached to the back. Notice that there's a tube attached to the port on the right-hand side of the gauge. Disconnect that tube and attach another tube to the right-hand port. Additional tubing can be found in your tool bag. We took the other end of this red tube and extended it into the area where the ducts are located. In this case, poked it under the basement door into the crawl space area. Next, we taped off a supply register with a piece of grill mask and inserted a static tip through it. The end of this clear tube is connected to the left-hand port of the manometer. Now, when we turn on the blower door, the pressure we'll read is the difference between the inside of the ducts and the crawl space duct zone. If you're using this handheld controller Infiltrometer model, it's a bit neater if you slip the tubes through the back like you see here. On a future program, we'll explain how to set the tubing up using different models of blower doors. In this house, we only taped off the one supply register that was used to measure the duct pressure. On the next program, we'll explain when and why you might have to temporarily tape off additional registers for the test. Before turning on the Infiltrometer, we need a data collection form. You can print one out from the house leakage test screen in the Infiltrometer Windows software by clicking on this button. Put the form onto a clipboard and ask the homeowner to help by writing down the readings. We'll cover all the customer education and sales related issues on a future program. We made sure to set the brass switches on the control panel to room and to test. We then turned on the Infiltrometer to depressurize the house. We're aiming to achieve 25 pascals pressure on the digital gauge. Don't worry about being exactly on 25, but try to be between 24 and 26. For this test, we settled out at 24.9 pascals. This is the pressure difference between the inside of the ducts and the crawl space where the ducts are located. Note that for this test, we will not be flipping the brass switch to measure the flow pressure in the Infiltrometer fan. We're just using the Infiltrometer as a pump to create the pressure that sucks air in through the duct leaks. It doesn't matter how much air is leaving the house through the Infiltrometer. We then took an air capture hood and went to each register and grill to measure duct leakage air coming in. This outside wall return is reading 92 to 93 CFMs. This inside wall supply is reading 28 to 29 CFMs. This floor supply register is reading 17 CFMs. In total, we took readings from 6 return grills and 10 supplies.
69 on the return.
Note that since we're depressurizing the house, the leakage air was all coming towards us, whether it was a supply register or a return grill. Since we're measuring under depressurization, we made sure the flow hood was set to read in the so-called supply mode, with the air coming towards the operator. If you were doing this test while pressurizing the home, you would need to change your setting on the flow hood to read in the so-called return position. When doing the test, you just record the readings on the form from each supply and return grill. On this particular case, the homeowner you see here writing down the numbers is Tommy Sin, who also happens to work with the member company TSC. Once all the readings are taken, turn off the fan and run the numbers through the Infiltrometer software program. We recommend that you use the Infiltrometer Windows software to add up and analyze all the duct leakage readings. The flow hood leak test is the fourth tab in the software. We explain the software operation details on the program called How to Use the Infiltrometer Windows Software Part 2, Flow Hood Duct Leakage and Efficiency Analysis. It's pretty simple to run. You just enter information on the house and system, and then all the supply and return readings. Press Calculate and Save when you're done. The results show up on the screen, and to get a printout, you load white paper into your printer and press Print Report. Let's take a look at the results on screen. This system has a total of 728 CFMs of duct leakage. In layman's terms, this is equal to a total hole in the duct system of 135 square inches. That would be a combined crack 1 inch wide and 135 inches long. This is almost a square foot of holes. How tight should the ducts be? Ideally, of course, they would have no leakage. One common standard or program requirement for new homes in some areas is to have less than 5% leakage. For this 2.5 ton, 1,000 CFM system, that would be 50 CFMs as you see here. In layman's terms, this is equal to only 9 square inches of leakage. In this house, therefore, the duct system is 15 times leakier than a good new construction system, expressed here as 1,500%. The next step is to estimate how this duct leakage affects the heating and cooling capacity and efficiency, using the fifth tab, the efficiency analysis. After entering a few more items of information, such as furnace size and where the return leakage comes from, the program calculates the results, and you can get a report on this pink form. For this system, under design peak load conditions, the air conditioning is estimated to lose 0.41 of a ton of AC, or 17%. It would of course have been much worse if the return air was coming from a hot attic instead of a relatively cool crawl space. The impact on the furnace is actually somewhat worse. It's estimated to be losing 41% of the capacity at peak conditions. The seasonal impact is also a concern. In this case, a new 12 SEER AC would only work as well as a 10.5 SEER without these problems. An 80% furnace is only working at 55% delivered efficiency. So, how did we fix the leakage problems the testing uncovered? Outside wall returns are both leaky and poorly insulated. Although ideally they would be abandoned, that wasn't appealing to the homeowner as the house had just been renovated. To fix the return leakage, the joist panning was removed and replaced with hard ducted flex. All the possible leaks in the cavities were sealed. One new 200 CFM floor return was also added to reduce whistling and static pressure. We'll show the sealing process step by step on a future program. The biggest benefit reported by the homeowner has been a significant reduction in summertime indoor humidity. The Infiltrometer flow hood duct leak test is usually very simple and easy to run, and will give you a very accurate measurement of duct leakage. But don't assume that all the tests are as easy as this one. This program is a good introduction, but it does not cover all the details you'll need to know to do the testing on a daily basis. On the next program, we'll go over all the little details, how to solve some problems you may encounter, and provide answers to the most common questions on the process. There's also a lot of information in the Comfort Institute training manual on how to perform the test. We also go over this test at our training classes. So do some more study, then get out and practice, and you'll soon find that it's a valuable advanced test to perform for your potential customers, and to check the effectiveness of sealing work performed. Thanks for watching, and we'll see you on the next program.